Hello friends, welcome to VK Lectures. In this lecture, we will be discussing about Fourier series. Fourier series. Now, Fourier series is expressing some function f of x if it is in the form of periodic function. That means f of x in terms of periodic functions like sin x and cos x. Now, if f of x is a periodic function with the periodicity a, then in general we can write the f of x equal to f of x plus a, where a is the periodicity. The function will have the same value at f of x as well as at f of x plus a. Now in terms of waves, this a is nothing but the frequency. Now uh, this f of x can be expressed in terms of sine and cosine terms. So f of x for any periodic function, it is written in terms of cos x and sin x in this way: a naught by 2 sum over plus sum over n an cos nx plus sum over n bn sin nx, and a1 and b1 are called first harmonics, a2 b2 are called second harmonics. Now these are different values. Now here we have a function f of x which is periodic in the range 0 to 2 pi. Okay. Now then f of x can be written as a naught by 2, which is the first term in the Fourier series, sum over n equal to, this moves from 1 to infinity, a n cos nx. So two terms, a n and cos nx, plus sum over n equal to 1 to infinity again bn sin nx. These are called cos terms and these are called sine terms. Now what are a naught, an and bn? A naught equal to 1 by pi. Integral is the integral from, this is the limits, that is from 0 to 2 pi f of x dx. This is the function f of x. Now an equal to 1 by pi integral, again the limit is the range of the function 0 to 2 pi f of x into cos nx dx. bn, which is the sine term, equal to 1 by pi integral from 0 to 2 pi f of x into sine nx dx. So this is the cos term, which is an, and this is sine term, which is bn. Now assume that we have a function f of x which is periodic function from minus pi to pi. This is an even function. The function f of x, which is in a Fourier series, remains same: a naught by 2 sum over n equal to 1 to infinity an cos nx plus sum over n equal to 1 to infinity bn sin nx. So now what is a naught? A naught is 1 by pi. The limits are the limits or the range of the function where the function is defined, minus pi to pi f of x dx. Again an 1 by pi integral from minus pi to pi f of x into cos nx dx. bn equal to 1 by pi integral from minus pi to pi f of x into sin nx dx. Now here, if f of x is even function, if f of x is an even function, then a naught can be written as 2 by pi integral, instead of from minus pi to pi, this can be 0 to pi f of x dx. Similarly, a n can be written as 2 by pi integral 0 to pi f of x into cos nx dx, and bn equal to f of x is an even function and sin x is an odd function. So even into odd, that is an odd function. So bn in the integral in the even limits will be 0. So bn is 0. So this you can please make a note of it. Similarly, if f of x is an odd function, then a naught equal to, so this is an even limit and odd function, so a naught will be equal to 0, and an will be equal to, this is odd function, cos is an even function, odd into even, odd function, limits are even, so even limit odd function, the integral will be 0. So bn will be equal to what? This is odd function, sine is also an odd function, 1 by pi integral, that even limits, so it will be equal to 2 by pi integral from 0 to pi f of x into sine nx dx. For a periodic function in the region 0 to 2L, now the range is slightly changed, it is from 0 to 2L, f of x, that is the Fourier function in a Fourier series, a naught by 2, no change, sum over n, and this is n equal to 1 to infinity, an cos n pi x by L, plus this is the cos term an, and the sine term is n equal to 1 to infinity, sum of bn sine n pi x by L, and a naught equal to 1 by L integral the limits 0 to 2L f of x dx, an equal to 1 by L integral from 0 to 2L f of x into cos n pi x by L dx, bn, which is the sine term, 1 by L integral 0 to 2L f of x into sine n pi x by L dx. Now if the function f of x is periodic in the range minus L to plus L, which is again a even limits, the function f of x can be written as the Fourier series as a naught by 2, no change in any of these quantities, sum over n equal to 1 to infinity an cos n pi x by L plus sum over n equal to 1 to infinity bn sin n pi x by L. Now if and a naught value 1 by L minus L to plus L f of x dx, an equal to 1 by L minus L to L f of x into cos n pi x by L, and bn equal to 1 by L minus L to L integral f of x into sin n pi x by L. Now comes if f of x is odd, or let us start with even. If f of x is even function, then we know a naught is equal to 2 by L integral 0 to L f of x dx, an equal to 2 by L integral 0 to L f of x into cos n pi x by L dx, and bn equal to 0. And if the function f of x is odd function, then a naught equal to 0, an equal to 0, and bn equal to 2 by L integral 0 to L f of x into sin n pi x by L dx. Even function. Now what is it mean by even function? If f of x is any function, then if f of minus x equal to f of x, then this is called even function. F of minus x equal to f of x. One example is f of x equal to x square. Now what is f of minus x? That will be equal to minus x whole square, that is equal to x square. This is nothing but f of x. So here f of x equal to f of minus x. Another example is cos x, which is also in we can write cos of minus x equal to cos x. Now coming to the odd function, if f of minus x equal to minus f of x, then this is an odd function. Examples are this is odd. Example is f of x equal to x. Now what is f of minus x? That's equal to minus x. That is nothing but minus, what is x? X is nothing but f of x. So f of minus x equal to minus f of x. Now another example is sin x. Sin of minus x equal to minus sin x. Now what do you mean by even limits? Even limits means when the integral has or the function has limits extending to both sides of 0 equally. That is from example minus pi to pi, minus L to L, minus infinity to infinity, okay, minus pi by 2 to pi by 2. All these are examples. That means towards the left of the 0 and to the right of the 0 there is equal separation or equal distance. Integrals, some few of the integrals that we need to remember. Integral from 0 to 2 pi cos nx dx equal to 0. Similarly, integral 0 to 2 pi sin nx dx is also 0. And integral 0 to 2 pi cos square nx dx is equal to integral 0 to 2 pi sin square nx dx. Both are equal to pi. Half into length of the interval formula can be used here, since this is full limit. So this is equal to pi. Similarly, this is also equal to pi. integral from 0 to 2 pi sine mx into sine nx dx equal to 0 only when m not equal to n. Similarly, integral from 0 to 2 pi cos mx into cos nx dx is also 0 and m not equal to n. This one, integral 0 to 2 pi cos mx into sine mx dx is equal to 0. Now seventh one, cos nx is cos n pi is minus 1 whole to the power n, and sin n pi is 0. F of x equal to x. Find the Fourier series, and the function f of x is in the region 0 less than x less than 2 pi. We are asked to find out the Fourier series of the function x. Now we know that x is not a f of x equal to x is not a periodic function, but still we can write the function f of x in terms of the periodic functions that are sine and cos. Okay, now according to the formula, f of x can be written as a naught by 2 plus sum over n equal to 1 to infinity a n cos nx plus sum over n equal to 1 to infinity bn sin nx. Okay. So what is a naught? You are going to find what is a naught here. So a naught equal to integral before that 1 by pi into integral from 0 to the limits that are 2 pi f of x dx, that's equal to 1 by pi times integral 0 to 2 pi f of x is x dx, it's equal to 1 by pi integral x is x square by 2, and the limits are from 0 to 2 pi. Now substituting for x, that is 2 pi, so 4 pi square by 2, so that's equal to 1 by pi into 4 pi square by 2. Pi gets cancelled, 4. This gives us 2 pi. So value of a naught equal to 2 pi. Now we need a n, that's equal to 1 by pi integral from 0 to 2 pi f of x into cos nx dx, f of x into cos nx dx, that's equal to 1 by pi integral from 0 to 2 pi f of x is x cos nx dx. So x cos nx, x integral derivative is 1. Again, if we take the derivative, it will become 0. Cos nx sin nx by n. Again, the integral gives us cos nx divided by n square with a minus sign. Sin nx integral is cos nx. Now the first term is x into sin n x by n, which is positive, multiplied by plus 1. The second term is 1 into minus 1 into minus cos nx divided by n square. So the limits or so 1 by pi into x into sine nx divided by n plus cos nx divided by n square. The limits are from 0 to 2 pi. Now this x sin nx, the limits 0 to 2 pi means it is 0. So 1 by pi n square, 1 by pi n square cos 2n pi minus cos 0. Again both are evens, so what it gives is 1 minus 1. Cos 2n pi is 1 and cos 0 is also 1, so 1 minus 1. So this implies an equal to 0. Now we have bn, which is equal to 1 by pi integral from 0 to 2 pi f of x into sine nx dx. That's equal to 1 by pi integral limits from 0 to 2 pi x into sine nx dx. So that's equal to x and sine nx. X derivative is 1, again 0. Sine nx is cos nx by n with a minus sign. Again the integral is minus cos nx, so that is minus sine nx divided by n square. This one multiplied by plus 1, this one multiplied by minus 1. So limits will be equal to 1 by pi x into minus x into cos nx divided by n. This is plus sine nx divided by n square, 0 to 2 pi. So sine terms 0 to 2 pi goes to 0, and here we have only, so first term minus x, so since it is minus, go with the lower limit, so x 0, so first term is 0, minus, so 1 by pi minus x means 2 pi by, this is n, cos 2n pi, that is 1, so that's equal to minus 2 by n. So this is equal to bn. Now here we have the formula, that is for f of x Fourier series, and a naught is given to be 2 pi, an equal to 0 and bn equal to minus 2 by n. Substituting for these values, f of x equal to x, that's equal to a naught by 2. A naught by 2 means 2 pi by 2 plus sum over n equal to 1 2. So an is 0, so second term is 0. Second term means here there is no cos terms, and sum over n equal to 1 to infinity. Bn is minus 2 by n into sine nx. So let's write down the terms. Pi plus, when n equal to 1, this will be minus 2 by 1 into sine x, plus when n equal to 2, minus 2 by 2 into sine 2x, then minus 2 by 3 sine 3x, and it goes on. So that's equal to pi minus 2 sine x minus sine 2x minus 2 by 3 sine 3x, etc. So that's the answer. Now sometimes for this answer f of x equal to x, that's given by these terms, sometimes the question will be to find the coefficient of sine 3x in the Fourier series. Fourier series for f of x equal to x. So for this question you have to find out the series and to also find the coefficient of sine 3x. So in this question, coefficient of sine 3x is minus 2 by 3. So if this is the question, then the answer is minus 2 by 3. Right. Or sometimes the question will be, what is the second term in the series? Second term in the series is minus 2 sin x. So the answer is minus 2 sin x. Or sometimes the question will be approximate the series to the first two terms or first three terms. So what will be the answer? Pi minus, so here the answer will be pi minus 2 sin x. Or even sometimes the question will be approximate the series to the first two terms with at x equal to say for example pi by 3. So you have to find sine pi by 3, which is equal to root 3 by 2. So pi minus 2 root 3 by 2. So that will be equal to pi minus 3. So these are different kinds of questions that can be asked based on Fourier series. See, here we have a question, f of x equal to minus 1 in the region minus pi to 0 and plus 1 in the region 0 to pi. Now for the function, if such question is given, we have to know since the limits, what is the limits? Limits is from minus pi to pi, which is an even limit. We just need to focus on now the function f of x. We have to find whether the function is odd or even. Now look at this function, f of x is minus in the negative region and plus in the positive region. So function is an odd function. So even limit and odd function, the values of a naught is 0 as well as an is equal to 0 because the function is odd function and limits are even. Now we need to find only the bn or the sine terms. So bn is given by 1 by pi integral, the limits are from minus pi to pi, f of x times sine nx dx. Fine. So now let's split this integrals. So integral from minus pi to 0, f of x minus pi to 0 is minus 1 times sine nx dx plus integral from 0 to pi, value is 1 times sine nx dx. And this is everything within the bracket multiplied by 1 by pi. Now the first term minus 1 into integral sine nx is cos nx by n, cos with a minus sign, so minus of minus plus, so 1 by pi into cos nx divided by n from the limit minus pi to 0 plus again 1 by pi, instead of cos we have minus cos, so minus cos nx divided by n in the limit 0 to pi. So 1 by pi into let's take n also out, 1 by n pi cos n pi. So cos is an even function, so cos n into minus pi, so cos of minus n pi is minus 1 whole to the power 1. So cos 0 is 1, so putting the upper limit first, 1, that is cos 0, minus cos n pi is minus 1 whole to the power n, so minus 1 whole to the power n, plus again 1 by n pi. Now here I have the minus sign, so I will go with the lower limit, so cos 0 is 1 and minus cos n pi is minus 1 whole to the power n. So it says 2 by pi or 2 by n pi, 2 by n pi into 1 minus minus 1 whole to the power n. Now this is there will be two values. First one is when n is odd, n equal to odd. Okay, when n is odd, it will become the bn will become, or yeah, bn equal to 4 by n pi. And second case is when n is even. When n is even, bn value is 1 minus 1, 0. So what is series says, f of x is equal to a naught by 2 plus sum over n an cos nx plus sum over n bn sin nx. So an and a naught are 0, so f of x will be only having b1 terms. So b1 sin x plus b2 sin 2x, etc. Now what are b1? b1 equal to what is bn? Bn equal to 2 by n pi into 1 minus 1 whole square. And what is b1? b1 is 2 by n pi into 1 minus 1 is 2, that is 4 divided by n pi. What happens when n is even? For n is even, this is 0, because 1 minus 1 will be 0. So the next term will be b3 sin 3x. So second term is 0, b2 is 0. Again, what about b3? b3 will be again equal to 4 by n pi. So the series is f of x equal to, you can take 4 by n pi outside or 4 by pi outside. 4 by pi when you take outside, the first term b1 is n pi, so this is equal to 4 by pi. So 4 by pi outside, b1, that is b1 is b1 is 4 by pi sin x, then we have plus this b3, this is equal to 4 by 3 pi because n equal to 3. So sin 3x by 3 plus next term will be sin 5x by 5. Now here we have a question, f of x equal to x square in the region minus pi to pi, so that is an even limit. Now find the Fourier series at x equal to 1, so value at x equal to 1, and show that pi square by 12 equal to 1 minus 1 by 4 plus 1 by 9 minus 1 by 16, etc. Now yes, let's find the Fourier series now. Now this is an even function. F of x equal to x square is an even function, and the limits are also even. So we know that a naught exists while an also exists, and bn does not exist because this is a sine function. So a naught is equal to 1 by pi integral from the minus pi to pi. F of x is x square dx. Now this can be written as 2 by pi integral from 0 to pi x square dx. So that's 2 by pi x cube by 3 0 to pi. So 2 by pi cube by 3, so 2 pi square by 3. So a naught equal to 2 pi square by 3. Now we need an, which is again equal to 1 by pi integral f of x is x square into cos n x dx. It's again from 0 to minus pi to pi. This can be written as 2 by pi integral from 0 to pi x square cos nx dx. So x square and cos nx uv integral, so x square becomes 2x, again derivative becomes 2, again 0. So cos nx integral is sin nx by n, again integral sin, so minus cos nx by n square, again integral is minus sin x divided by n cube. Now here it's multiplied by plus 1, multiplied by minus 1, multiplied by plus 1. So here itself we can take a call that 0 to 2 pi sine integrals will go to zeros. So this is 0, this is also 0. So 2x into cos nx by n squared. So it's 2x into cos nx divided by n square, moving from 0 to pi, and the lower limit is again 0 here. And that gives us 2x, that is 2 times pi, 2 pi by n square, 2 into x pi, so that is cos nx is cos n pi, so that is minus 1 whole to the power n. So this is an, and we know bn is 0, bn does not exist. So here we have to multiply by 2 by pi an, that is, this is only x square cos nx dx integral. So this is multiplied by 2 by pi, what we get is pi gets cancelled, so an is equal to 4 by n square into minus 1 whole to the power n, and a naught equal to 2 pi square by 3. Now according to the formula we have f of x equal to a naught by 2 plus sum over n equal to 1 to infinity an cos nx, and we know that bn term is 0, so we can write f of x is x square equal to a naught is 2 pi square by 3 by, and divided by 2 you get pi square by 3 plus n equal to 1, n when substituted for 1, so you get 4 minus 4 into cos x, then we have plus minus 1 whole to the power 2 into 4 divided by 2 square, that is again 4, so 4 by 4 into minus 1 whole square, this is into cos 2x plus then 4 by n square, that is 3 square into minus 1 whole to the power 3 cos 3x, etc. Now at x equal to 0, this is the question, find the value at x equal to 0. So this left side becomes 0, that is equal to pi square by 3 plus minus 4 into cos x or cos 0 is 1 uh, minus sorry plus this yeah, let's take plus 4 here, minus 1, or let's minus 4 into plus 1, minus 1 by 4 cos 0 again 1 plus 1 by 9, and this is minus 1 by 16. This goes now this would be equal to pi square by 3, just bring this to the other side, equal to 4 into 1 minus 1 by 4 plus 1 by 9 minus 1 by 16, etc. And this can be written as, bring the 4 to the other side, so pi square by 12 equal to 1 minus 1 by 4 plus 1 by 16, sorry 1 by 9 minus 1 by 16, etc. The Fourier series of the function f of x in the period 2 pi is f of x equal to a naught by 2 plus sum over n an cos nx plus sum over n bn sin nx. F of x equal to 0 from minus pi to 0 and 1 from 0 to pi. We need to find b1 by b3, which means we want to find bn basically. Okay, so bn equal to 1 by pi integral, the limits are from minus pi to pi, f of x into sine nx dx. So f of x here, let's write down the, when you split it you will have only value in the first region, so 1 by pi integral 0 to pi sine nx dx. So that's equal to 1 by pi into sine nx is, integral is cos nx divided by n is with a minus sign, and the limits are from 0 to pi. So that's equal to 1 by pi, limits, since it is minus sign going to the numerator, sorry the lower limit, so n I am taking it out, so 1 by n pi into cos 0 is 1 minus cos n pi is minus 1 whole to the power n. So that is bn, so bn equal to this one. Now what is b1? b1 equal to 1 by n is 1 pi into 1 minus 1 to the power 1. So that's equal to 1 by pi 1 minus 1 2. And what is b2? b2 is 1 by n pi, that is 3 pi into 1 minus 1 whole to the power 3. So that's equal to 1 by 3 pi into 1 minus 1, that is 2. And what is b1 by b3? b1 is 2 by pi divided by b2, sorry this is b3. b3 is 2 by 3 pi, so this will be equal to 2 by pi into 3 pi by 2, that is 3. Now we are going to see the Fourier series for Dirac delta function. Now Dirac delta function is given by f of x equal to delta of x minus a, and where a is the center of this Dirac delta function, and it is varying from minus pi to pi. Now the Fourier series we have to define in the range minus pi to pi, and in that case f of x can be written as in the Fourier series as a naught by 2 plus sum over n equal to 1 to infinity a n cos nx plus sum over n equal to 1 to infinity b n sin nx, while a naught equal to 1 by pi integral from minus pi to pi delta of x minus a dx, that is equal to 1 by pi into 1, and this will be equal to 1 when the center a lies between minus pi to pi, and the value will be equal to 0 out otherwise. Okay, so we can write for the Fourier series defined in the range minus pi to pi, a naught value equal to 1 by pi. Similarly, a n equal to 1 by pi integral from minus pi to pi f of x into cos nx dx, which is a n. Substituting the value for f of x, that is Dirac delta function delta of x minus a and cos nx, then center will go and occupy this position x, so that will be equal to a n is 1 by pi cos n a. For bn equal to 1 by pi integral from minus pi to pi f of x into sin nx dx, that's equal to 1 by pi integral from minus pi to pi delta of x minus a into sin nx dx. So a will take the position at x, so that will be equal to 1 by pi, that is bn 1 by pi into sin n a. So we have the function f of x equal to delta of x minus a equal to a naught by 2 plus sum over n equal to 1 to infinity a n cos nx plus sum over n equal to 1 to infinity b n sin nx. Now substituting a naught value, a naught is equal to 1 by pi, and a n equal to 1 by pi cos n a, and b n equal to 1 by pi sin n a. So that's delta of x minus a equal to a naught by pi, that is 1 by pi into 1 by, so 1 by 2 pi plus sum over n equal to 1 to infinity a n is 1 by pi cos n a plus sum over n equal to 1 to infinity 1 by pi, sorry, here we have cos nx also, cos na into cos nx, 1 by pi into sin na into sin nx. So that is Dirac delta function Fourier series. And this one we can also further write it as 1 by 2 pi into 1 by pi can be taken out, sum over n equal to 1 to infinity cos na into cos nx plus sin na into sin nx. So cos a cos b plus Sine A sine B is nothing but cos of A minus B. So here it is cos Na minus cos nx. So further, delta of x minus A equal to 1 by 2 pi plus 1 by pi into sum over n equal to 1 to infinity cos of n into x minus A or A minus